All righty. Welcome to another episode of Engineering Talks. My name is Tyler Hoeven, and I'm going to be talking today about a precept proposal for Turing-complete smart contracts for Stellar. Precept simply means that this is just some work that I've been doing on a Stellar ecosystem proposal around this idea of Turing-complete contracts. And we're going to talk a lot about that today, obviously. That's what the talk is all about. But it's important to kind of reset your thinking a little bit. We all have an idea of what Turing complete or smart contracts means. I'm going to try and come into this without too much baggage and explain what I mean a bit along the way. And I'm going to be using Ethereum as our comparison project because most of us, when we think of smart contracts, have Ethereum in mind. So this is not necessarily a competition against Ethereum. It's simply a comparison of features that if this SEP were accepted and used, how you would accomplish similar sorts of things that you could on Ethereum on Stellar, and comparing the functionalities and features that Ethereum offers with what this Turing signing server SEP would allow you to accomplish on Stellar. So let's dive in. Today's going to be a bit technical. We're going to go through, try and blaze through these slides pretty quick, and then get into some examples and code. But it will be a little bit longer probably than we're used to for these engineering talks, so stick with me. It is quite interesting. I'm super excited. I've spent a lot of time thinking and working on this problem myself as something that I very much need in my own development. And I think would really benefit the Stellar community at large. All right. So the problem is Ethereum has market dominance in an arena we're better suited to serve, namely finance. So we have assets and the ability to have assets as first-class citizens where they're held in an account, but oftentimes financial architecture will be built in Ethereum in instances where oftentimes it would be better to have that built in Stellar, as it's going to be faster, cheaper, and you're going to have this capabilities and functionalities that aren't native in Ethereum, and you'll have to kind of custom build that yourself, whereas in Stellar they will often be built in kind of at the base layer. So our solution here is to appeal to Ethereum developers by bringing functional feature parity, and that's a key phrase here, functional feature parity. This isn't feature parity, it's functional. So what you can accomplish in Ethereum, trying to allow that same type of functionality in Stellar in the financial arena. And so the solution there for me, the product there for me, I guess, is smart contracts. Now, we have a concept of smart contracts in Stellar. It's kind of using operations and this nature of Stellar transactions. You can accomplish a lot of different things atomically inside of a transaction. So you can have lots of different operations that open things up and close things off, all within the same transaction. You don't have to do a bunch of individual things, and then who knows what's going to happen inside, because lots of things can happen in a single ledger. You can accomplish a lot of very intelligent, smart things, and by using things like time bounds or pre-signed transactions, you can get away with a lot of I would say complex business logic, and we've sort of slapped smart contracts onto that, but in no way is that what most of the world thinks of, or at least most of the blockchain world thinks of when they think of smart contracts. Smart contracts as a concept is very different than what we tend to talk about when we talk about Stellar smart contracts today. So we're going to be moving away from what most of us think of when we think of Stellar smart contracts and moving much closer to what Ethereum means when it says smart contracts. So my definition is a smart contract as the ecosystem understands it. So regardless of what Wikipedia says a smart contract is, the way that smart contract, the word, the phrase is used as the ecosystem at large, the blockchain ecosystem understands it, is an arbitrary Turing-complete program. It's Turing-complete programming executed on a decentralized network for the purpose of minimizing trust. So you have this idea of a program that has arbitrary programming that does who knows what, that accomplishes some sort of goal, and that goal is better accomplished when it's trust minimized, or there isn't a lot of third-party trust involved, or it's decentralized. And this is important to kind of for all of us to agree, even if you don't necessarily agree with me on this, that this is where I'm coming from when I talk about the smart contracts that I'm envisioning through this SEP that I'm building is this idea of trust minimizing trust. So there will still be trust involved. There's always trust involved. It's just who and how much, and what are those parties that you're trusting. And then arbitrary Turing-complete programming, the ability to do kind of any sort of logic that you need um, to create some sort of output. In Stellar, you don't have that. Stellar is not Turing-complete. That allows it to be very fast and flexible and scale very quickly. Whereas in Ethereum, those things are bundled together, where you have, well, we'll get to it in a minute, the idea of transaction creation and execution. So what does that really mean? What is the ecosystem doing with smart contracts? There are two things when it comes to financial smart contracts. There's transaction creation and transaction execution. So building blockchain mutations, basically these are the instructions for how I want to change the ledger, how I want to mutate the existing state of the ledger or blockchain by adding another block. And then also the transaction execution, which takes those instructions, takes those mutations and actually runs them to perform the changes. So you have the instructions and the execution, the creation and the execution. So we have that, right? In Stellar and Ethereum, you can both create transactions and execute transactions both in Stellar and Ethereum. So what's the big deal? What's the problem? Well, the problem is decentralization. In Stellar, there is no decentralized transaction creation. In Ethereum, there is, because in the virtual machines that run Ethereum, those are run all over the world. Anybody that's running an Ethereum node and participating in the consensus, the transaction creation and execution both happen in that process of arriving at consensus. Whereas in Stellar, only the execution of a transaction, the creation of that transaction happens outside of the execution. So you sort of give it very detailed and permissible instructions and then send it to the consensus protocol to actually execute that. In Ethereum, you send it very minimum information, and then both the creation and execution, because assets are not first-class citizens, you can build a whole program that will handle the kind of input that anybody might send it, and then the ledger for your particular smart contract will be updated. So both of those things happen at the same time. That would be one of the reasons that Ethereum is built the way that it is, and why it some of the reasons or ways that it differs from something like Stellar, which we're not going to get into that too deeply, and I honestly don't understand it perfectly. But with my new this SEP proposal that I've been working on, and we're going to look at today, we're looking at adding decentralized transaction creation. So smart contracts do not execute. This is really important. And something that's very different than Ethereum. All that I'm adding or proposing that we add through this SEP is decentralized transaction creation, which we will then tag on to the existing architecture we already have within Stellar, the decentralized transaction execution, which would give us through this, what I'm tagging as SEP-X. If we add Stellar and this new SEP-X together, we get functional feature parity with Ethereum, where we have decentralized transaction creation and decentralized transaction execution, which would be amazing. And we'll get to why. Hopefully, maybe some of your wheels are starting to turn on what decentralized transaction creation would allow us to do, some of the things that it would allow us to accomplish, which we cannot do now, but we'll get into that. So essentially, SEP-X is Turing signing servers, decentralized Turing-complete transaction creation. So a few weeks ago, we had a engineering talk on SEP-30, which is the key recovery servers, and we have federation servers as well. So we have this concept within Stellar ecosystem proposals of external servers or services which run to provide sort of additional logic or additional functionality, common additional functionality across the ecosystem. And so this would be an additional server that would be running that individuals or enterprises would run, which would allow this decentralized Turing-complete transaction creation, where you have these multiple parties running something which will accomplish some goal in a decentralized way. So Stellar smart contracts via SEP-X have three entities. They have users, contract creators, and Turing servers. So some of these may be blurred at times, the line between the two, but they are distinct in the sense that regardless of whether they end up being the same entity or individual, they will be serving three separate purposes. So users submit transactions for final execution. They're the final interested party. They have something that they want to do, something that they want to accomplish. And they interface with Turing servers, but it's typically transacting through a contract, not the Turing server. So there'll be contracts that users interact with, and those contracts are hosted on the Turing servers. So I will interact with a contract which is hosted on multiple Turing servers. And then there are contract creators, obviously, who create the contracts and either provide services or just innocuous features. So we'll get to some of those in a minute, but a contract creator doesn't necessarily have to be some sort of service provider. They can just build a contract that anyone can implement and use to provide some additional decentralized functionality. And so I have a diagram here, which is 100% useless. So we are going to break that down. User wants to interact with a contract creator for the service they're providing. So you have users and contract creators. And we have this concept already today where you have some third party that you're wanting to interact with your Stellar address, whether you're making a payment or you want to provide some sort of functionality or interact with some sort of functionality that a service provider is offering. And you have a very one-to-one relationship. You send instructions or requests, you interact with their UI, and they send you back responses, whether that's sign this transaction or add this trust line or whatever that interaction might be. It's very much one-to-one. And this is where some of the issues are going to arrive. This is unacceptable as a requirement. Oftentimes this will be fine, but I think it's not the right thing to say this is the way it has to be, right? So it's unacceptable as a requirement, as it leaves the user trusting a single entity and the contract creator liable for a high level of responsibility and involvement. And ultimately, it's not decentralized. You could add more servers, but ultimately the contract creator is controlling all of those servers. And decentralization, like at its core, is mitigating trust or taking that trust and splitting it amongst multiple parties so that no one entity controls everything. We split that up to where there's a level of trust because no one entity is the single trusted entity. And so we were getting to that diagram I showed a little bit before. We introduce a third disinterested but incentivized third-party service, the Turing signing server, which will act as a permissioned request arbitrator between users and contract creators. To this server, we upload a strict, specific turing-complete program or smart contract, which will create transactions. They don't execute, they create transactions. So the contract creator will build a program which will create outputs. It's basically just in my case, it's going to be a Lambda function, but ultimately it's just an API endpoint, which when called takes an input and then outputs a valid transaction, Stellar transaction. And then the Turing signing server, as you can see here, stores contracts and holds keys. And those keys are Stellar keys, which sign for the transaction that the contract generates. And in Stellar, we have this concept. The reason this works or is valuable is because in Stellar, we have the concept of multisig, where you've got multiple signers, which can be added to accounts and can sign for any transaction that's being originates from that account. So if I want to make a payment, I can sign with my key, or I can sign with somebody else's key if they've been added as a signer to my account. And so as we start to, we create this contract and we upload it to a Turing signing server. When we upload it, a signing key is sent back to us. And that signing key is what we upload to our contract. We add that signature to our contract, or we give it to our user to add to their account so that we can sign for some action off of their account. Now, when we have just one Turing signing server, we're going to see that doesn't get us any improvements, but it's the duplicity, the lots of Turing signing servers where we start to see the power come out. But this allows for transactions and their signatures to be generated following the strictness of a codified contract rather than the trust of a contract creator entity. And this is the big point here. That's may seem a little bit abstract, but it's really powerful, because if I want to do something, let's say I want under very strict specific circumstances, I want you to be able to use my account to pay yourself $100. If some parameter is met. I can't ever give you my secret key, because if I give you that, you can do much, much more than just pay yourself $100. So how can I give you access to my account without giving you complete access to my account? It's only strict, specific, Turing complete access to my account. Well, I get that through this contract creation where I upload a contract to a Turing signing server, and then you interact with that Turing signing server. And rather than you having access to the secret seed, you have access to only perfectly signed transactions from those Turing signing servers. So I don't give you a secret key. I give you signed transactions through these Turing signing servers. And then you can interact with the Turing signing servers rather than directly with my account. And that's kind of one example, but hopefully that starts to make sense. So the reason this becomes, or how this becomes decentralized, is we upload these contracts to lots of different Turing signing servers. So it's the same contract across lots of different Turing signing servers, and then through thresholds, right? So we are able to add multi-signers, multi-sig to accounts, but each of those can have a threshold. So I can say to make a payment, you need a threshold of 3. So I need at least a weight of 3 to be able to make a payment. And so when I upload all of this same contract to all of these Turing signing servers, they all send me back a key, which I add to my account as signers, but only with a weight of 1, so that no one Turing signing server, not even 2 Turing signing servers, could sign for or collude to do something with my account. You would need at least 3. And through thresholds, you can add any number of, I guess, up to 20 thresholds to create very complex, secure logic to account for whatever kind of logic you're trying to perform with your contract. But essentially, you're just going to upload this to a number of Turing signing servers, and then through thresholds, decide how many of those Turing signing servers need to add their signature to the transaction that's being requested. And because it's the same contract, it's producing the same transaction, the same XDR. And if any one of these gets a little sneaky and tries to, make a payment to themselves, they would change the XDR, and therefore the signature for all the other Turing signing servers would be invalid. If the request that the user is making to the Turing signing servers is different than any of the others, it will be rejected. It'll be spat out because it doesn't match any of the others, and the signature therefore would be invalid when it finally comes to submission time. And so now the contract creator is a non-entity. They no longer really interact with the user. The user interacts directly with the Turing signing server. So contract creators don't even need to, at this point, run a server. They just uploaded some arbitrary JavaScript logic, or really any programming logic, language logic, to these Turing signing servers. And so long as it's valid and producing good transactions and being used and not being nefarious, the user can interact with Turing signing servers completely separate from the contract creator in a decentralized manner, getting transactions which follow the pattern that the contract creator allowed for because they've added their signature to it. And in this case, following our example before, the user can begin interacting and making payments to themselves for $100, so long as it follows the pattern that the contract creator allowed for. So hopefully this is starting to make sense. Turing signing servers allow for secure, decentralized transaction creation and signing through programmable contracts. So again, we need to remember that Turing signing servers, their goal is to create transactions, not to submit them. So they perform the business of creating a valid signed transaction. And that signing doesn't have to be, and often I would say is not, complete. It's partial signing. It's signing for some of the logic of the transaction that was performed, but there's probably should be some piece that's left to the user, whether that's paying the base fee, whether that's in a vending machine example, you have to pay 100 lumens to get 100 of your asset back, like in a ICO model or some sort of token giveaway, or there's lots of different instances where the user is going to be the final signer. And so the transaction that comes back is signed, and it's signed enough for all the interaction that deals with the contract creator's account, but there's still some piece that's left for the user account. So it's just adding signatures to a transaction, but not necessarily fully signed, although that obviously could be. Again, the business logic of here is in the contract, not in the XDR itself, not in the Stellar transaction itself. So you can create all kinds of business logic that produces a transaction at the end of the day that could be any sort of thing. And that's kind of what we're going to look through here now. So again, like the motto for this is you get what you permit. So when you start talking about could I do this or could this be used in this case, the answer is going to, as long as it's related to like seller transactions and getting a payment and kind of relegating access to your account through a secure contract, like so long as that's the question, the answer is yes, because so long as you create the right permissions, it's you can allow for it. You can build for something like that. Amazing, but how does this compare to Ethereum smart contracts? We'll just look through this really quick. Stellar now with this SEP-X would have, along with Ethereum, decentralized transaction creation and decentralized transaction execution. And then the difference here, arguably, is going to be, again, the safety over liveness that we have within the Stellar consensus protocol versus Ethereum virtual machines anyway, where the safety aspect, the contract control, it's just creating transactions. It's not actually executing them. And so you don't have to necessarily worry about your accounts or about the safety of your accounts, so long as you've built your contract correctly. And then the liveness aspect of it is going to come down to how well did you write your contract? Is your account funded? All the things that are already limitations just within Stellar versus the Ethereum model, which is once you upload a contract, there's nothing you can do to really alter that because both transaction creation and execution are happening at the same time. But that contract will always exist. It will always be up unless you have some of those non-decentralized backdoors open. So some of the core philosophical design differences: Stellar smart contracts, nothing unacceptable can happen. In Ethereum smart contracts, nothing unexpected can happen. And there's benefits on both sides. It really depends on what you're trying to build for. With Stellar smart contracts, because that is just generating a transaction, the final execution is in the hands of whoever the final user is. Whereas in Ethereum smart contracts, the final execution is in the hands of the contract. So you execute it hoping that it does what you expect. Whereas with a Stellar smart contract, you execute it and then it spits out a final transaction, which you have the final say in whether or not you want to submit it. So finally, the thing that we were all looking forward to, examples. And I think, yes, that is pretty much my last slide. I'm going to switch now to my browser. I'm going to open, I've got some glitch demos here. So fantastic little service here, glitch, and I'm going to open up all of these examples. And then make this a little bit bigger. So the first one I'd like to look at is a very basic kind of run-of-the-mill vending machine example. So when we talk about smart contracts, vending machine is kind of a really good starting point where you give it an input and it gives a guaranteed output. So in this case, we're running a Tyler coin trade or swap where you send in 100 lumens and you get 100 Tyler coin back. Or it's always a 1-to-1. So if you did 50, it'd be 50. If you did 10, it'd be 10. So I've got an account here. See if I can open this. I've got an account here, which I am making a payment to. And this is just a standard Stellar account that I funded with FriendBot. There's nothing fancy that's been added to this. There's a contract, though, that I've uploaded that says all the logic around when a transaction or when a request comes in to this contract, take 100 lumens, make a operation for taking 100 lumens from this account, and then send it 10 Tyler coin, or 100 for 100, 1-to-1. And so we'll give it that 100, and then we'll generate the XDR. So let me just pop in the code for this real quick. Try to make that a little bigger. So this would be our vending machine smart contract. So essentially there's a contract that says when a request comes in and it has source and amount, we're just going to build a Stellar transaction and then spit out the XDR. And that's going to be a payment for 100 lumens to me, and then send back Tyler coin to the source account, which is the account that we add right here. And then it also adds the fee payment to the turrets, so to the Turing signing servers. So Turing signing servers, again, I mentioned that they are disinterested but incentivize third parties. They have no benefit to get from collusion, but they have benefit to get from collecting on fees. So if you run a Turing signing server, you can charge fees to execute these contracts as well as upload contracts. So Turing signing servers have a business opportunity, but they're disinterested in the sense that they don't care what contracts are being run. So this is a very, 57 lines of code plus comments. So very, very small little contract, but it does allow arbitrary logic, and it allows me to safely say, I can run an entire contract here of paying out my Tyler coin in exchange for XLM all through just this very basic JavaScript code. So I'm going to upload this. When I upload this contract to a Turing signing server, they are going to send back a signing key, because this is the account, this is the contract address that is going to be paying out Tyler coin. If we look this up in Stellar Expert on the testnet, we will see that when we upload it to the Turing signing servers, they send back signing keys, and those signing keys are what we add to this contract to allow for these contracts to actually generate signed transactions, because the Turing signing server is going to generate an XDR and then add a signature using whichever signing key they have for that contract. And then we have a threshold of 3, like I mentioned before. So so long as 3 addresses sign off on this, any transaction that's coming from this contract, we can generate a valid signature, and the execution of the transaction will go through. In this case, paying out Tyler coin. So let's go back here and generate that XDR. That generate XDR button is going to call the Turing signing servers. It's going to say, hey, this account would like to generate an XDR. And it looks like we have got a beautiful error. So, it's always the way it goes. But essentially, what would have happened if it had worked would be the contract goes out to all of those different addresses, all those different Turing signing servers, sends back the same XDR with a signature. Those signatures get added to the transaction that comes in. We add our final signature to the XDR, to the transaction, and then we can submit it, right? So we have this account we would have to sign for that 100 lumen payment. It pays out the 100 lumens, and then the signatures that we received from the Turing signing servers for the Tyler coin are all valid. All the signatures are there. We can make this relatively complex payment all through a very simple Turing signing server smart contract. So that would be our vending machine example. The next one would be, let's do this weather coin. So this one kind of showcases what I would call oracleized data, but really it's just taking a third-party API and using that information to generate a different transaction, or a variable transaction. So in this case, we are using the dark sky API. We are looking up the weather at my current location. And if it's raining, we are going to generate a transaction for rain coin. And if it's sunny outside, we're going to generate a transaction that pays out sun coin. And so again, we need the same address. When I upload this, the same thing happens. Each Turing signing server sends back a new signing key. We add that signing key to the contract, and then the contract, when we call it, will generate signatures for this particular transaction. So hopefully this one will work. It's not raining at my house at the moment, so unfortunately we can't get any rain coin. So in this case, it's looking it up and it's saying because it's raining, we're not going to be able to get any rain coin. So if it was raining, you'd be able to get rain coin, but because it's not, I think there's logic actually running in the glitch app which says if it's not raining, don't generate the XDR. So maybe a little bit of a letdown, but still you can provide arbitrary logic to say, because it's not raining in my house right now, we're going to spit out and reject this transaction, which is really cool because you allow that logic to say, I'm going to give away like usage of my account, but only under certain parameters. And in this case, it's an arbitrary third-party API, which is providing the information that says, well, it's not raining. And so because it's not raining, we're not going to generate a transaction. We're not going to add a signature for it. We're throwing that out, which is cool. The next one would be the filter smart contract. And this one's actually a little bit different, because instead of adding signatures to a contract address, we're actually adding signatures to an account, to a user's account. And this is one of those examples where a contract, the ones we've looked at so far have been sort of third-party services. So somebody's actually trying to run a business off of smart contracts. In this case, somebody's just created a random, open source smart contract which provides filtering functionality. So maybe I have an account that I want to give access to someone for, but only if their XLM payments are below 100 lumens. So I've made a filter smart contract here, which basically says when a transaction comes in. So the input here is actually an XDR. So we're going to generate a Stellar transaction, which has to have just one operation, which is a payment, and it has to be an amount that is less than 100, because if it's greater than 100 lumens, the request will be rejected. But in this case, we actually want to attach this contract to a user's account, not to a contract account. So there isn't really a contract address here. Somebody's just created this contract and says, hey, I'm going to upload this. And if you would like to use it, if you would like to get this filtering functionality for your account, then you just need to add the signing keys to your address. So if we take this XDR here, which is a valid example, we can look up the account that it's attached to. So we've added the signing keys to this account. And right now there's just two. So we've uploaded this contract to two Turing servers, taken their signing keys and attached them to our account. We have a threshold of 3, which means we need all 3 of these, both Turing signing servers and then our own TFI signing key to sign off on. And then we kind of have this escape base 64 or SHA-256 hash that if something terrible happens and we need to rescue this account, we kind of have that in our back pocket. That's not a Turing signing server thing. That's just good practice if you've kind of locked out your account to yourself. But anyway, Turing signing servers are going to sign for 2. So by themselves, these Turing signing servers can't do anything. There's no collusion capability possibility, because at most they would only have a weight of 2, which isn't enough to do anything. They would need that final signer, my signature, to actually do anything. So, however, I can't also by myself do anything. This account is useless on its own. It needs those other 2 Turing signing servers to actually accomplish anything. And those Turing signing servers are locked in to only signing for this, which is that the transaction is greater than or is less than 100 lumens. So if we go back here, we can see this payment is for 100 XLM. So if we go and we generate the XDR on this, all of my examples are failing today. This is not fantastic. And we try the invalid one, it works. It doesn't, it filters the transaction here. Looks like this one's not working. I think I may have uploaded the, it's all beta, it's beta. Let me look real quick at the contract address and make sure I'm actually using the right contract address, because this one is kind of cool. So we edit our project real quick in our JavaScript. No, it's got the right one. Who knows? Probably shouldn't have fooled with it too much before doing the demo. But anyway, if you had a valid example, which this is valid XDR, but looks like something's up with my Turing signing servers. This would be valid. It would be signed. You could view it in the laboratory and then submit the transaction to the network, so long as it was under that 100. One more example here that's on Glitch is our hourly wager demo. So I play video games occasionally, and on Fridays we'll do wager pools. So maybe like 10 lumens or $20 or something like that, and then that all gets pooled together, and whoever wins the game gets the pool. You could also see it as a donation pool, where or even like a Kickstarter or something, where if a balance reaches over a certain threshold, then the money's released. There's lots of different smart contract logic that comes through these types of functionalities, but you don't want a single entity holding all those funds with the risk that they could run away. And so you might add multiple human signers to that, but if one of them gets bitter and doesn't want to do the thing that like, oh, you cheated and I'm not going to sign off on this transaction anymore, you could run into issues when you have those human variables. But if it's just machines and they're just following contract logic, you remove that layer or that risk level and do perform that trust minimized aspect of things, which is really what we're after and what Turing signing servers exist for. And so in this case, you have a contract address, which has the Turing signing service been uploaded to all of the Turing signing servers with a threshold of 3 again. So you need at least 3 of these Turing signing servers. And then individuals will start to pay this account. You can see the payments coming into this account, into the wager pool. And then in this case, every hour, the contract will go through. You'll be able to generate an XDR, which will pick at random one of these individuals as the winner and pay out the pool to them. So again, if we go to our hourly wager contract, it's a little bit longer contract, but not really, still 100 lines, where it takes into account the operations for this contract account, looking at the payments, and then we'll randomly select one of those as a winner every hour. So those are examples in that case. Again, you would upload the signers in this case to the contract like we did before. The last one that I think is really interesting is a recurring revenue model. So one of the issues right now with recurring revenue models on Stellar is that you have to pre-sign loads of transactions and kind of bump sequence numbers, and it gets quite hairy when it actually comes time to execute those. And so you have to pre-sign loads of transactions, especially if it's like shorter terms on weekly or monthly basis. And you have a lot of these transactions just kind of sitting around hoping that they'll be valid whenever it comes time to submit them. With Turing signing servers, you can create a contract which takes into account when a payment was last made, and for how much it was, when it was made, all the information around the actual payment. And then if it's been a month since the last payment, you can make another payment. And so essentially you would create this transaction, much like the filter transaction, or much like the filter contract. You upload this contract, add the signers to a user account, but those signers can only sign through this contract. And so if it's been a month since the last payment was made, you can call this contract and it will generate a transaction which makes a 1,000 lumen payment. But as soon as you submit that to the network, and you try and call it again and say, hey, I just want to keep collecting thousands of lumens from this account, it's going to say, hey, it hasn't been a month since the last time we ran this contract. So in that case, you don't have to have any pre-signed transactions. You simply wait until the time comes, you generate the transaction, and you can actually generate it and submit it through some sort of third-party service. The user wouldn't necessarily ever have to know, other than they would still have ownership over their account. And if at any point in the future they wanted to cancel their subscription, they would simply remove your Turing signing signers from their account, and any calls to that account to make a payment would fail because the user removed the Turing signing server signers from their account. So I think if this account still exists, we could actually look at the signers that have been added for this account. Looks like it's not on that one. I think it's on this one, actually. Yeah, so we've got the 2 signers here, but then it's also got a threshold of 2. So while we need both Turing signing servers to be able to generate that recurring payment every month, if at any point the user wants to remove those signers, they're able to do that because they have a weight of 2 set on their operation threshold. So that's been a basic overview of what I have so far on Turing signing servers. It's still a work in progress, obviously. If that's something that seems interesting to you, and hopefully it does, I am looking for more people to get involved on actually building out smart contracts. So I have quite a few Turing signing servers, just testnet Turing signing servers set up. They're ready to be used. ready for people to poke around and see what's possible. Hopefully some of these examples have gotten your wheels turning. But now is kind of the announcement for we need some people to start using this thing, to start poking it around, to see if this makes sense as a SEP, to see if we've built the right thing. And then towards the, as that sort of happens and we sort of get a better idea of what this should be and how it works and does it work and what kind of contracts can be built using this, we'll move into the actual draft, the SEP draft portion, where we write it all up. We have the API endpoints. We showcase how to build one of these servers and run it successfully and all the fees around it, and how to generate revenue, how to run a secure Turing signing server, but also how to create good contracts. And then hopefully we can get it to an active state where it starts to be used more and becomes a normal sort of used active stellar ecosystem proposal within the ecosystem, where these Turing signing servers become possible, where anybody can spin up a contract and upload it to a plethora of Turing signing servers. And then beyond that, it's just the acceptance of it, and it becomes a normal part of Stellar development. All right, so that was long. Apologize for that. Apologize that the demos didn't work out great. Hopefully we'll have those back up and running so that everybody can play around with what we have so far. Should have that within the next couple of days and linked on the YouTube. Let's go for questions. I hope there's a couple of questions that you guys have for me as things pop up, and I will begin to answer those, and then we'll close out. But as you have questions for me, feel free to type them into the chat, and we'll walk through them. Otherwise, you can find me on Twitter and Keybase at TYVDH. I would love to chat. All right, how is this relevant for cross-border payments? Where does this fit in decentralized finance? Well, you kind of said it there in decentralized finance. A lot of it's going to boil down to what you mean by decentralized. Everybody kind of has their own idea of what decentralized means. And when it comes to things like decentralized payments for cross-border payments or decentralized finance for cross-border payments, it's going to come down to like who's in charge, who's in control, and what are the differences, or what layers do you have when you're talking about ownership. So in the case of an anchor, for example, and wanting to facilitate payments being made in and out of the ecosystem, or putting up offers on the order book to maintain liquidity between assets. Right now, all of that's done in a completely centralized way where an entity controls their order books, and so long as those orders are out there, they're free to take them down. And when you have these cross-border payments moving back and forth, that can become an issue if a large portion of the success happens on one entity maintaining liquidity. So it would be possible that a liquidity provider could create a smart contract that creates order books that are decentralized, where they don't have the ability to alter or remove the orders, that it just runs the liquidity and doesn't remove itself, doesn't have the capability to remove itself. So a lot of it has to do, I think, with removing barriers towards trust. And this is actually kind of interesting because that's one of the biggest barriers when doing cross-border payments is, do I trust them? Are they going to do what I expect them to do? By using Turing signing servers, or really by adding decentralization or trust minimization into your workflow, into your business logic, you're able to guarantee some level of trust because you relinquish some portion of control, whether that's liquidity providing or making good on payments. The more that you can guarantee through math that something's going to happen versus guaranteeing through goodwill, or I have a good business plan, or I've done this in the past, the better off you're going to be when it comes to winning people's trust. And I think that's going to become true more and more as other businesses do that and say, you don't trust us, you verify through the code that we've written that we don't ultimately control. We've relinquished control of our secret key, our ability to alter the state of the ledger to these Turing signing servers, which ultimately own the contract. They run the contract through users interacting with it. So in that sense, depending on how it's implemented and at what level it makes sense for a company to add in trust minimization to their business logic, Turing signing servers will be useful for cross-border payments or decentralized finance. But a lot of it, again, is going to ultimately boil down to what does decentralization mean, and is that actually helpful when it comes to trust minimization or making payments across borders. Is SCF going to run a Turing signing server? Who runs Turing signing servers without any incentive? I don't think SDF is going to run a Turing signing server. I mean, I run a couple right now just as testnet demos, but there is tons of incentive to run a Turing signing server. We didn't talk a whole lot about fees or uploading contract fees, but that's a big part of running a Turing signing server. It would be kind of a separate talk to what is it like to run a Turing signing server, but you can charge XLM fees. So basically part of the XDR, when a Turing signing server spits out a transaction, part of that transaction is payments to the Turing signing servers. So those would be small fees paid out to the Turing signing servers, as well as fees for actually uploading a contract. So it might be 10 or 100 lumens or 5 USD to upload a contract to a Turing signing server. So there's both the incentive for people to upload contracts, but also to run good Turing signing servers so that you can continue to collect on fees as Turing signing servers are executing smart contracts. Don't understand why you need signed transactions with other party. When you share your signed transaction with Turing signing server, owner of Turing signer can execute your contract. Only if that Turing signing. Let me read the question. I really don't understand why you need Turing signing servers to share signed transactions with other party. When you share your signed transaction with Turing signing server, owner of Turing signing server can execute your contract signed transaction to attack you. Again, that's only if you allow that. How did you write your contract? Because some contracts may accept a incoming XDR, but it doesn't have to be a signed transaction that's coming in. It's just instructions, or it's just a contract. It's just a transaction that's been submitted to a Turing signing server, but it doesn't have any signatures on it yet. And if you write your Turing signing server contract in such a way that the output is a partially signed transaction, so not full, where you still need to sign for the source account, you still need to sign for those fees maybe, but there's still another signature that's needed. The transaction is only partially signed. It's not viable to submit to the network yet. So ultimately, yeah, a lot of it is going to boil down to trusting all of the Turing signing servers together. But you already trust that with the way the Stellar consensus protocol works, where you trust the individual nodes that are running Stellar. So this idea of disinterested but incentivized third parties is quite strong, and it has been proven to work quite well. So ultimately, it boils down to, again, you get what you permit. And if you allow for the generation of a transaction that is completely signed and valid, then yes, the Turing signing server could submit that. But even that isn't necessarily an issue unless they're submitting something that you don't want them to submit. It ultimately depends on what that transaction does, what that transaction accomplishes. But because you're splitting up your secret key between lots of different Turing signing servers, any single one probably shouldn't, unless you've allowed for it, be able to do anything on their own. They would need to collude with other Turing signing servers to actually accomplish anything dangerous. So what's the difference between sharing your signed transactions contracts with Turing signing server over traditional servers? The only difference is, I mean, they're traditional servers just operating as Turing signing servers. Ultimately, it boils down to who owns the Turing signing servers, because if you own them, there's not decentralization there. But if some other entity owns those, some other entity is running those, so long as, again, you're uploading it to multiples of those, you're running sort of it's not a clone, but it's similar to how Stellar works already, where SDF and Lobster and CoinQuest all run validator nodes, and you submit a transaction to their network, and they validate the transactions and perform the operations within those transactions. This is kind of the same thing, where you have a secret key which is split up amongst lots of different servers, and those servers then add their signature to any transaction that's coming from the contract, and so long as it's valid and it's all the same and it's a valid signature, it can be submitted to the Stellar network. How would you see this used for subscriptions like you mentioned before? Also, does this support more than just JavaScript? So I gave an example on the subscription model. Ultimately, you would just have contracts that were built for different amounts, or it could maybe take variable amounts. I haven't thought too deeply about exactly how it would be used. My purpose isn't to be too stringent on how it should be used, and more provide a platform that works and then allow other people to build on top of that. So you kind of would have to think, okay, if I can either get ownership over someone's account, but in a very controlled way through contracts, only through contracts, or I can give ownership to my account, but only through strict contracts. What does that allow for? What are the capabilities there? And then there's tons of them. And subscriptions would be one of those. With fee bumps, I don't know. It'll be interesting to see if fee bumps kind of gets rid of the issue with recurring revenue, since you can pay sequence numbers and fees from different accounts now. So some of the issues we had there may already be gone. I haven't looked into that too deeply. But when it comes to complicated or Turing-complete recurring revenue models, where you need to do much more beyond just paying fees and sequence numbers, you actually need to do some logic, external logic, or take in accounts of the person's account, like refunds, or, oh, they partially paid and now we have to perform some logic around some sort of partial payment, or upgrades, and more Stripe-like functionality. Then you could use something like this to accomplish that through the Turing signing server or smart contract logic. And again, do you need to do that? I don't know. That depends on how much your users need and value a decentralized option for something like this, or a decentralized option. And maybe they do, maybe they don't. That ultimately is up to the users and what they expect out of the services that they're making use of. All right. Do we have any other questions? Those were good questions. And again, this isn't set in stone. This is very good discussion, and we don't want to spend our time doing the wrong thing. But at the same time, all you have to do is spend a little time looking at Ethereum to realize that smart contracts and Turing-complete smart contracts is a very powerful tool that is very valuable. And I think it's worth us taking a look at, is there opportunity? Does it make sense for us to include some sort of functionality like this, functional feature parity, that would allow for decentralized transaction creation, where you don't have to trust the person who's creating the transaction. You can mitigate that. You can relegate that through other parties. All right. Super duper. I appreciate everyone hanging out. Again, feel free to reach out on Keybase or Twitter with follow-up questions. I'll try and get working links to these demos, as well as some API docs for people to poke around. If you want to get involved building these things or testing it out, be sure and reach out and let me know. Thanks again for coming out, and we'll catch y'all later. Bye.